Hello, can everybody see me and hear me?
Yes.
Yes, okay, great. Well then, I guess we shall kick off. My name is Dr. Jane Hurley, and I've got the pleasure of being your chair today for the second annual Early Careers Conference. I am the head of the Earth Observation and Atmospheric Science Division at RAL Space, but I've had a number of different roles since I joined the space industry some time ago, starting first as a scientist, moving on to design and development of space instrumentation, operations of those space instruments, being a project manager responsible for those instruments, to heading up the Space Engineering and Technology Division at RAL Space, and now on to the Earth Observation division here. All of this to say, today is about showcasing various careers and roles in the space industry and giving examples of how different people got to where they are today. And to give you an opportunity in a really kind of inclusive, informal situation to ask questions of different people. I really wish that I had had this sort of opportunity when I was starting out. So yeah, please do try to take advantage. There are no such thing as stupid questions. Only people that are really, really passionate to talk to you about what their current role is, what their past roles have been, and how they've gotten to where they are today. So the people that we have as speakers and panelists today all have very different backgrounds, different trainings, different pathways to their current roles. And in fact, their roles are covering a wide range of different roles that are in the space industry. So there's no one right way, I think, is what we really want to emphasize today. What they do have in common is that they're really passionate about their jobs. They love talking about them, and they're excited to interact with you all today. So ask questions on the slides here. You can do it via the question and answer Q&A way, and you can upvote. I'm not quite sure how this works, but I guess you put that you like it or thumbs up or something, and it increases the weight of each of the questions. You can also do it via email, ralspaceevents@stfc.ac.uk, and we'll pick those questions up and pass them on to our speakers and panelists to discuss. Okay, can we have the next slide? Thank you. So just some brief logistics. The agenda for today is on the screen. So we will start with a series of talks. In between the talks, we will have quizzes that hopefully you can engage with. And obviously we'll have answers before we move on to the next speaker and to indeed our panel session. So yeah, do please engage with them. I can't pretend that I would have gotten the answers right if I was doing them unprepped. So just a reminder that at the end of our scheduled sessions, we can stay on the line for an additional 30 minutes if people have particular questions that they want to take advantage of the panelists or speakers to talk through, or if there are particular things that you don't feel comfortable asking in the larger, more formal setting throughout the day. Okay, so I think that we will probably move on to our speakers. Our first today is Temi Shogolola, who is head of innovation in the Inspiration Programme at the UK Space Agency. I think we will go to a break with a quiz question while we get everything set up and ready to go. Thank you very much.
Thanks, Jane. Just going to check if everyone can hear me.
We can.
Brilliant. Good morning, everyone on the line today. My name is Temi Shogolola. I am the head of the Inspiration Programme here at the UK Space Agency. And the aim of the sort of Inspiration Programme is to just try and help us connect with general public, to get them to understand how important space is to our daily lives. It's also all about exploring and inspiring people to take up STEM as a subject. So for people who have never considered, going into STEM or going into space agency, so we work with organisations all across the UK, working to inspire young people. And we're looking at both technical and non-technical roles. And finally, it's all about working with industry to ensure that they've got the skills they need. In the UK, we're looking at more about launching. From here in the UK, we're looking at how, we do space sustainably. So we want to ensure that the space sector has the skills that it needs to deliver that. And my team and I work on a daily basis to help us deliver that. In my briefing, I was told this is all about talking about my career in the space agency, my journey to to working in the space agency. So I'll start with how I joined the civil service. It was never in my plan. My plan was to go work for an investment bank or working for one of the big fours, make loads of money and retire at 30. And clearly I took the wrong path because I'm a civil servant, but I absolutely enjoy what I do. Not every day, but most days I enjoy what I do. And when I started in the Cabinet Office, I saw a 3-month internship and was persuaded by all these incredible people that I worked with that working in the civil service was exactly what I wanted to do and where I wanted to be. So I come from a non-STEM background, but one of the beauties of working in the civil service is the chance to work in areas where, you're not technically trained on, but working with subject matter experts to not only help you develop your skills, but to help you deliver the projects and the policies that we have to do. So after a few months in the Cabinet Office, went to work at what was known as Department for Exiting the European Union. So the day after the referendum, I was asked to join a team helping to set up the department, helping us to highlight what the negotiation process is going to be, what our role is going to be. And soon after that was delivered, I went to work at the Ministry of Defence, working on the shipbuilding strategy, and it was all about delivering, ships for the Royal Navy for the next 30 years. And it is still one of my favourite jobs that I've had in the civil service, getting to work with naval personnel here in the UK, globally, and promoting the UK and our export abilities. And I was in that post for 2 years, then moved over to BEIS, so the Department of Business, Energy and Industrial Strategy, working on economic shocks. So 2 weeks after I joined the team, Thomas Cook went into insolvency, and just many nights trying to deliver that, trying to expect about 1.5 million Brits from across the world back into the UK. Absolutely an incredible experience. And then I saw this opportunity to work at the UK Space Agency on space sustainability. Sustainability was something that I'd worked on at BEIS for a while, and it was just such an interest, plus my interest in space. It was almost like two passions merged into one. So yeah, I went to work there for a year and a half, developing what space sustainability means for us here at the UK Space Agency, what it means to the UK, exploring how we define space sustainability, how we measure our impact in the projects and the policies that we deliver, and just generally working collaboratively with the UN, the US, and all our global partners in defining and understanding how we all measure that we're doing the work we're doing is as sustainable as possible. In that role, I was also the project manager for the active debris removal project. And, it was an incredible experience to work with industry on what does a solution look like? Is it something we in the UK can actively sustain and do and deliver? And we could. So we are currently working on it. We're working with international partners to see how this becomes a global project, a global matter, something that we deliver not just for the UK, but in collaboration with ESA and in collaboration with other space agencies across the world. What does my average day look like? So I currently have a team of 4, but we'll be expanding in the near future to be 11. We would usually on a top of the end of the week talk about what our deliverables are for the week. So who are we meeting? So we do a lot of engagements, as I mentioned. with industry, with academia, with sector, so the space sector, but also with global agencies. So we don't want to just build capabilities here in the UK. We want to be able to support our global partners and working in collaboration to deliver, universal projects. So we work with so many agencies across the world, NASA and JAXA and the Australian Space Agency, the Canadian Space Agency, all looking at skills, whole ensuring that we can support young people with their goals. So if you're a young person who has never thought about space as a possible sector you want to work in, we want to make sure you have the skills you need. We want to make sure you know the pathway to get in there, and more importantly, we want to make sure the people in your lives have the resources to help you deliver that. So I would say my usual day starts around 7:30, 8, breakfast, and I usually would have a call with my senior leadership team. At the moment, skills is a big part of what I'm working on. So I do have a number of meetings with industry and colleagues in UKRI and STFC and UK SEDS and so many different organizations, just talking about how can we support, do young people, are they aware of, what they need to be doing, and just making sure, the goals we have as an agency is delivered in an effective way. My team is made up of technical and non-technical colleagues. So I do have colleagues who are engineer trained, who might have done a STEM background, and I have colleagues that have non-technical skills. So, helping working collaboratively to help us deliver the objectives. For the UKSA, as I mentioned, we are an organisation that, constantly looking at about the future of space, what we're doing right, what we're doing wrong. So there's a lot of collaborations across the agency. So I work with the spaceflight team, I work with the launch team, the exploration team, just making sure that the work we do is in collaboration. One of the things we manage is the STEM Ambassadors program. So constantly trying to get colleagues to get out and speak to young people. So we work with the National STEM Learning Centre to train staff here in the UK and encourage industry to do the same. For some of you on the call today, we've got that might be interested. We do some internship program called the SPIN internship, so the space internship, and it's an 8-week-long program where young people can go and work in space sectors, work in space companies, and get tangible experience. We sift through every single company that applies to make sure you're actually doing, tangible work. So you won't be stuck, making coffees or doing admin. You're going to be doing work that is, intangible with your degree. So we are currently working on launching that for next year. So if anyone's interested, do drop me a message on LinkedIn and I can share further information. But we do this with Catapult to deliver this program. So yeah, I would say my career as a whole has been very diverse. I've always picked and worked for departments that I'm genuinely interested in, departments that I'm curious about on how they do what they do. I've worked on projects that are fascinating. It's not every day you can say, you helped procure destroyers and frigates for the Royal Navy, or that you got to see the Queen Elizabeth aircraft carrier being tested, or, working on with, astronauts. So currently work a lot with Tim Peake on his sort of social engagements. So it's been, very much been led by passion and interests, and I think, and curiosity as well. So yeah, that is all from me. If you have any questions, please do feel free to ask. Thank you.
I might just jump off the start while people are thinking of their questions, Temi. Thank you very much. It was a very interesting talk for sure. One of the things that I always struggle with myself is when you are doing a role that you don't feel like you have a technical background in, particularly in this sort of industry? And I don't know whether or not it's just, you know, being plagued by self-doubts, but how did you feel coming from a non-STEM background into your current role? And how do you deal when somebody starts talking to you about a particular technical matter that you don't know anything about?
So I think the first thing I do is get to know my colleagues very well, because again, I'm a generalist, but I'm fortunate enough to work with so many subject matter experts, and just getting to know them on a personal level, on a professional level. It means, you know, if I'm ever, you know, I would say my first sort of month to 3 months is just getting to know my colleagues, because there are going to be so many questions, especially when I go to events where I'm just like, I don't know about IOSM or this or that. You know, I can always exactly. I can always like count on colleagues like, what does this mean? What does this, especially acronyms are like the worst. And it's like, what does this mean? How would you use it in a context? What kind of questions will people ask me? And I think I would say probably most of my roles have been quite technical. And I think I've always been very keen on taking those complex technical work, because it is very challenging, but it helps you develop so much. It helps you develop your skills. It prepares you for your next role. So you're literally got so many examples for your next job. But yeah, I think very much relying on colleagues and being very open that I'm not from a technical background, so I will be reliant on your knowledge in doing so.
And I think also, you know, this is a sort of industry where the boundaries are always being pushed, and it's quite an acceptable thing to say, I don't know. And that's the very nature of what we're doing. Yeah. I'm just looking at the Q&A here, and we have a question from Eva, who asks, which is the favorite part of your job?
In my current role, this is the first time where I actually get to see the impact of the work we're doing. So having worked previously on projects, your project might not become live for another 20 years, or, you know, you're working on a policy that might not be delivered for another 15 years. So you never really get to see the end of stuff unless you're coming at that very final phase. This is the first job I've had where I get to get out of the office. I've seen more of the UK than I've ever seen before, and just getting to see the impact of the work we're doing, engaging with young people. Over the summer, I did a lot of work with the Royal Air Force cadets, and getting to see just how, you know, just a few sessions talking about space, they all kind of were so inspired. Some chose to go do like a space-based degree at university, and I think within the work I'm doing, you're genuinely working with people that are passionate on making an impact. So literally just working with people that are passionate about what they're doing, and just getting to see like the amazing work, the impact of the work we're doing.
Okay, fabulous. We have a question from Holly. It says, do you think we feel the effects of space sustainability when looking for potential employees? Do you think it's something that puts people off careers related to space due to lack of awareness around sustainability in space compared to that on Earth?
Absolutely. So when I worked on the active debris removal project, one of my role is to raise public awareness. You know, a lot of people know space, and the first question is like, why are we spending so much money on space where we could be spending it on Earth? But we rely so much on space, rely so much on space technology and space data. Our ability to fight on sustainability here on Earth is enabled by space. Our understanding of the impact of what's going on Earth is due to the data and information we're getting back from space. But the average person does not know this. They think about technology, but on like above technology is space technology. So yeah, it was just trying to get people to understand the damage we're doing in space, but also the opportunity. So I remember talking to a colleague at Astroscale, who was like, in the 60s, we had about 5 debris in space. And now we have over 1 million debris in space, and most of them are less than, you know, 10 centimeters in diameter. So trying to raise that awareness that, you know, we rely, so what we don't want is an important satellite to be destroyed by a little bit of like a small piece of debris. But again, it's raising that awareness for the general public. I think in the UK, we are at the forefront of that fight globally. And we have taken a lot of investment. I'm doing a lot of work to raise that. but also working with industry and organization, whether it's in the arts or and the creative industry, to help us raise that awareness of space sustainability and really, putting our money where our mouth is, and just making sure that, it's going to be a slow work, but we're really working with as many people to help us raise that awareness. I hope that answers your question.
Yeah, it does. I don't know, Emily and Hannah, there was a question at the top that's now popped off, but from a WOT that seems to have fallen off the... Oh no, I can find it again. Sorry, this is just a user error of me not being able to comfortably use Zoom. How can UKRI and UK Space Agency deal with the problem that only citizens of a given country are able to apply for a role? So this is international prospects of universities that would like to be recruited by a space organization, but can't because of the international, I guess, visa regulations.
Yeah, so one of the things we're trying to do more is understand within our sort of skills is how do we tackle the deficit we have in the UK? So in delivering that, we are working, my team and I are working with as many organisations across the UK. So DFT, the Home Office, sometimes whether we need a special space visa, for example, we're looking at, the work we're currently doing with ESA. Obviously, it's a lot bigger and a lot more global. So, do we encourage young people to go through that route? But we're also working with agencies in the global south as well, to not just in collaborating on projects. So those skills and for those young people internationally get to work on a UK project, get to work on, a satellite that's co-owned between the UK and another country. So it's something we're thinking of. Is the beauty of working in space is just how diverse it is, and just how no matter what skill you have, it is relevant in this sector. But yeah, it's something we're thinking of. We currently run a project with I've forgotten. It's on my head. But I've forgotten. It's with the British Council, and it's a chance. I'll pass on the information, but it's a chance for students, international students, to apply to work for a UK organisation for between 12 months and a year. I forgot what it's called. But yeah,
you can drop it in the chat.
Yeah, it's definitely something we're looking at and working on, and trying to understand how we encourage as many people from around the world to come to the UK and work within the space sector, and also nurture skills here in the UK.
Absolutely. I think we have time for one final question before we move on. Question about work-life balance. Do you find it hard to work from home in your role? And how does it compare to the more technical roles where presumably you have to be on site a bit more?
I think work-life balance has been one of the biggest thing here in the civil service. So from when I joined here in 2015, I worked from home. So I worked from home once a week. And as a few years in, it became twice a week, just for sort of mental health. And, so it's something that's quite embedded here in the civil service. We went through a massive technology transformation in 2015 to enable people to work from home and support that sort of work-life balance. Sometimes the scales are tilted where it's more work than balance, but at the same time, it's we have things like ensuring that if you spend extra time at work, you get that time back. We have really good annual leave. So yeah, work-life balance is definitely something that's embedded. I work from home 3 days a week, but if I decide to work from home 5 days a week, we have the technology to ensure that's enabled. We have something called a work passport. So if you're someone that's differently abled, or you need sort of adjustment with work, that is put in your passport, and you can take that along with you across your career. So whatever department you go to, they're informed before you start to make sure they make all the reasonable adjustment. But personally, I would say, yeah, it's there. But it's all about, I always say this, before I start a role, I put all my cards on the table. So that would be my advice. Put all your cards at the table right at the very beginning. Week 2, week 3 is slightly too late. So before you start a role, these are the days I work from home. this is what my personal life looks like compared to work. Can you accommodate that? So that would be my advice for any young person. Be very open from the very beginning.
Okay, fabulous. Thank you very much for a wonderful presentation and a very good and open discussion of our panelists' questions, our audience's questions. Are we going to show the poll questions at this point? Oh, perfect. Thank you, Hannah. I'm not sure. Can other people see it? I'm just seeing that you're starting your screen sharing. Up there we are. Righto. So question number 1 was, how many people have stepped foot on the moon? And the answer, which I'm told about 50% of you got right, was 12. 2 of the 3 members of each of NASA's Apollo missions, 11 through 17, walked on the moon, apart from Apollo 13 that didn't manage to land, but made it back safely to Earth. Fabulous. Okay, thank you very much. Now, our next speaker is Ian Horsfall, who is the head of dynamics at RAL Space. And I believe, Ian, you're going to talk us through career, role, and skills development.
Hello, I'm just going to see. I just need to share my presentation.
Thank you. Oh, I'm told, Emily, are we going to break for 5, you say?
Yes, just to allow us to do the second poll.
Great, thank you very much. So I believe there will be a poll that comes up on people's screens.
What was my password?
Okay, I think that we are primed and ready for Ian to start. So Ian, when you're ready. So I think we have the poll results up here from the oops, sorry, I have things popping up here. From the break poll responses. So Helen, Rosemary, John, and Megan are British astronauts. Helen was the first British person to go to space in 1991. Rosemary has recently been selected for a new class of career astronauts, along with Megan, who is now a reserve astronaut. And John has been selected for the feasibility study for disabled astronauts. Second one, British astronaut Tim Peake's ISS mission called. It was called Principa, which was named after Isaac Newton's famous books on the universal mathematical laws. Okay, I suspect we're able now to go to Ian.
Right, okay, I shall just share my presentation.
Fabulous, thank you.
Okay, well, good morning. My name's Ian Horsfall. I'm the head of the Dynamics Group, which is part of the Environmental Test Department at RAL Space. We're basically an MOT testing station for spacecraft. So what we do is we take things that RAL Space or other people have built and we test them to make sure they're ready to launch and they're going to perform as they should do. So I'm going to talk a little bit today about what I do and also to some extent how I got there. So here's just a little view of the sort of Dynamics Group's activities. So the picture at the top right there shows two of my graduates actually helping with a student rover competition over the summer. So just gives a fairly interesting thing attached to the machine there. So basically what we do is we take spacecraft hardware and make sure it'll survive. Primarily in my area in dynamics, we're about launch. It's about vibration and shock and acoustic load and all the other things that the spacecraft are subject to on the way up. If it's something like a lander, so it's like going to Mars or the moon, then we'd also be testing it to make sure it could survive the landing environment, which is actually more severe than launch. But primarily what we've got are vibration tests. We've got ways of shaking a test item, whether it's an individual component or a whole spacecraft. We can subject it to shocks to simulate the explosive bolts and the separation mechanisms and the various jolts it gets on the way up. And I have a group of 9 people doing that. There are 7 graduates, 2 of us with PhDs. I have a couple of people who come up via the apprenticeship route as well. In fact, I'm my sort of deputy head of group, my principal test engineer came through that route. So that's a very good way into the business as well. You don't have to come to the graduate route. And I also have one undergraduate intern, actually, Emily Bond, who's helping run this event. So I'm currently aiming to have one undergraduate intern every year in my group and just keep that as a rolling position. So in terms of what we do, so the top right shows our shaker there with a lunar rover, a mock Mars rover on it. And what we do is we take a piece of equipment, we shake it. We do tests which characterize it, which work out whether it reacts in the way we'd expect it to do. So we sweep it and we sweep through frequencies. We look to see where it resonates and to see whether that matches a model of that already exists of the test item. And then we also subject it to a type of random vibration which simulates the launch environment. And then we go back and we check to see if the resonances are still in the same position. So that's normally what we do with vibration. And what we're really trying to do there is several things at once. These days, a lot of things are numerically modeled. We do quite a bit of numerical modeling. In fact, one of my members of staff is a dedicated numerical modeler. So she runs finite element analysis on test items and our machinery. And these days, we'd expect most things that we're testing, particularly whole spacecraft, to have a very good numerical model. And so what our vibration test is doing a lot of the time is just checking that the real thing responds in the same way as the model does. In fact, we're verifying the model, and that then means the person building it can go away and do lots more tests on the model without having to have the expense and the risk of breaking the real one. So a lot of our job is to actually just verify that the thing works the way it does and to verify a model of the test item. Then we do what's called a workmanship test, which is really our way of saying we give it a shake and see if anything falls off. And so the random test, which is a sort of simulation of launch, is there to make sure the thing will react properly. It won't, nothing comes loose, none of the bolts loosen off and nothing falls off it. And then we keep doing these surveys of it just to check that all the resonances stay in the same place as we go through. Our shock test is slightly different in that what we do is we subject it to a shock, a very high level test equivalent to it, not quite like it being dropped, because if you drop something it gets a single pulse at relatively low frequency. We're more interested in explosive loads from separation mechanisms, so we subject to a very high G level for a very, very short period of time. And the bottom right picture there shows our shock test machine. The not particularly visible black device right in the middle, sat between Hannah's shoulder, just off Hannah's shoulder there, is the test item. In this case, it's actually a CubeSat dispenser or a NanoSat dispenser, and this was the first use of our shock machine a couple of years ago, and that was qualifying that pod to go up on a SpaceX rocket and dispense some nanosats into orbit. So that's one of the few things that I've actually sat and watched that's actually now been launched. Although what quite often happens here is we don't actually test the flight item, we verify that the design works, and the flight item only goes through a very limited amount of testing. Most of the testing is done on essentially a prototype. And then across the bottom, this panorama here is our new lab. So we're changing at the moment from testing small items, components and small bits of spacecraft, up to testing full-sized spacecraft. And the panorama there is of our new vibration hall, with Sandy, one of our graduate engineers, who's actually running one of the test programs at the moment from our site up in Edinburgh. And this is our new lab, which allows us to test very large items. So a lot of my job at the moment is to do with that and equipping that. So we're going up from testing single components and sort of shoebox size devices up to testing full spacecraft, up to sort of bus sized items. So things maybe 6 or 7 meters tall and weighing maybe 6 tons. So typical day. So I don't do a lot of the hands-on work. I'm relatively new to the aerospace, to the space industry. But I left my previous job in the defense industry almost exactly 5 years ago, and I came to RAL Space 4 years ago. I'm never going to be a deep technical expert in the operation of our machines and in some of the detail of the operation. And what I do instead is to manage a group of test engineers who do that. So most of my job is really managing them. And my aim is to make sure I have the right people in place at the right time, ready to do the job. So it's about getting the right people in, hiring the right people, getting them trained, and then making sure they've got all the skills and the equipment necessary to do what they need to do. And that then comes to getting equipment. So particularly as we're trying to equip a brand new lab, we're spending a lot of time, and really about 2 days a week of my time is at the moment just spent going out and buying stuff and checking stuff and all the things to do with deciding what we want, then going out and specifying it, get someone to build it, getting them to come in and install it, and then for us to commission it and train our own staff to use it. So the picture on the right there is a thing called a mass properties machine, and this is another test that we need to do. If you're going to launch a spacecraft, you need to know not just how heavy it is, but you need to know how it reacts to loads on it, particularly to propulsion loads on it. You need to know where its center of gravity is very accurately, and you also need to understand how easy it is to turn it. So if you take a pen has a center of gravity somewhere in the middle. We know where the center of gravity of this. I'm not sure it's in this pen here. It also has inertia, and it has, if I roll it between my fingers, it's very easy to roll. It has a very low inertia along its axis. It has a much higher inertia in these directions, and we need to know what those inertia values are. We need to understand its full mass property, so we can program the maneuvering system on the spacecraft to tilt it the right amount. So we need to know its center of gravity, and we need to know its moments of inertia. And this big machine you see on the right there is a mass properties machine. What it does is it ever so gently wobbles the spacecraft. So the bit from the sort of the center, the polished area down, is a test machine, and the big tripod affair on top is a is just a test frame with some weights attached to it to simulate a spacecraft. And what it does is it very gently wobbles that in 5 degrees of freedom. It measures where the center of gravity is to within about 1 millimeter, and it measures its mass properties. So that's quite a big part of my job. And that was me actually going to the factory in Berlin and looking at that being built. And next week, I'm going to America to look at some more equipment. The other bit we do is a lot of tracking and documentation. So I spend a lot of my time putting together quality assurance tracking systems for what we do, making sure we record everything we do. And then the sort of exciting bit at the end is then answering some of the technical questions and supporting the proposal for future work. So down at the bottom there, that's a picture of a spacecraft, is the aerial Space Telescope, which is a RAL Space spacecraft, or at least a RAL Space payload. To give you an idea, the sort of center part of that is about 2 meters across, and we're currently designing the test process for that at the moment. So a lot of my work is going into helping with some of my test engineers design how we're going to do that. So how I got here, I'm not sure whether I'm never sure whether it's a good I'm a good example or not. I've sort of gone from one thing to another through quite a career in a number of different areas. I suppose there are 2 threads. One is that I've done the lifelong learning. I've carried on doing courses and doing more qualifications. And in fact, the most recent qualification I did was in space science with the Open University in 2018. And I noticed Temi said in her presentation about learning the acronyms. Well, one of the very useful things about doing that course, coming from a different industry, was just to learn the acronyms. So I started out as a materials technologist or a metallurgist, and I did my degree at University of Surrey in '84. I worked on metal composites for many years. I then became a lecturer in ceramics at Cranfield University, and then spent about 10 years running a test group, running tests on armor, so body armor and tanks and aircraft armor and things like that. And quite a lot of work on stab-resistant body armor, which is what that picture on the bottom right is. And I actually got a PhD in stab-resistant body armor. And that was designing a test specification for police body armor. And a thread that's run through my career, largely by accident, is running test labs. I've run mechanical test labs. I've run microscopy, electron microscopy labs. Ballistic and stab test labs for body armor, and now spacecraft test labs. So that's sort of it's gone through that, and actually it's all remarkably similar. It doesn't matter whether you're trying to test a Wellington boot to test whether it's leak proof, or a shopping trolley that'll take shopping, or a spacecraft you can launch into space. What you need to know is, does it do its job? Can you test it to make sure it does its job? Will it reliably do it? And how do you instrument it to do that? And the sort of instrumentation tends to be accelerometers, load washers, or force measuring devices, and strain gauges. And I've used things like that for maybe 40 years now. So that sort of and I went through I spent about 30 years doing the sort of defense area testing, or it was actually defense, but anything to do with impact. So the stab work there you see at the bottom right, and then the top left is actually me out on a big explosive range, actually blowing up bits of electrical equipment to look at the safety of large electrical generating equipment. So we were exploding very large pieces of electrical equipment. Then the reason we're all dressed up in our boots is we then had to go and find all the bits and work out how far they'd gone in order to design systems to catch them and know how far away people had to have their offices from big bits of equipment. So it's sort of I've just sort of followed my nose. I've always wanted to be a rocket scientist, so that's what I wanted to do. I'm a child of the '60s. I sat up watching the space, the original space race in the '60s, and that's what I really wanted to do. It just took me about 40 years to get there by going from one thing to another. So that's really sort of how I got there, and what I do. And I think that's about used my time up. So I'll hand back to the Master of Ceremonies to
Fabulous, thank you, Ian. And I think that's a really good message, that that we all have these transferable skills that can be used in different ways. And and you don't have to enter into a career and expect to stay there for the next 30, 40 years. While we're just waiting for questions to load up, I have a quick question myself. Obviously, you don't want things to fail. but what is the most exciting failure that you've seen?
I don't know. Luckily, I don't think we've had very exciting ones. As people, I think one of my engineers said, and I'd asked the same question the other day, saying a good day is a boring day.
Yes.
We on vibration, it's very rare for things to fail. We understand vibration very well, and the people designing spacecraft instrumentation understand it. And occasionally you'll get a screw come loose, and occasionally something will maybe slightly rearrange itself, but we don't really see much. I think the most exciting phase are probably that rover competition I showed you the picture of. In fact, that was really quite useful because the rovers had to be put together with very quickly and very cheaply by the groups, and they didn't necessarily react very well to the vibration loads we put into them. And it actually was quite useful because normally our tests are quite boring. We don't actually get to see what a failure looked like. And the rover competition, there is actually a video on Twitter on the RALSpace channel where you can see us. The good ones just sat there and did nothing, were rather boring. The more floppy ones will quite disassemble themselves quite spectacularly, and that was actually quite interesting to see. And I know my test engineers quite enjoy doing that.
Great. We have some questions coming up from people here. Nicola wants to know what experience you look for when you're hiring people.
Well, our group is quite I think in terms of experience, you either want it depends obviously what level we're hiring at. I think the bit we find the most difficult to assess is maybe the practical skills, particularly in these days, particularly over the last couple of years. We in recruiting the undergraduate interns, it's actually been quite interesting to see what happened in that when we started doing it 3 years ago, which actually just as the pandemic started, we could ask practical questions and get very good answers, whereas for the last couple of years we found that people are lacking the practical skills and the practical experience. And it doesn't mean you've got to have experience building spacecraft. It means you've worked in a university, you've run lab classes, you've gone out and built things, you've done Lego, and certainly I try to look for practical skills and some evidence that people can work with their hands, because it is actually handling things. You're going to be up on with our spacecraft now, you're going to be up probably on the top of a cherry picker 10 meters off the ground trying to stick a strain gauge onto the side of a spacecraft, so having some degree of proof of manual dexterity and being able to work with your hands is useful. It doesn't mean you have to taking cars apart. Anything from knitting to craft to building Airfix kits or working with 3D printers and anything like that. So I think the practical skills is what we look for. Obviously, as you go up in seniority, then you look for more level of skills where you're starting to then look at, and the two sets of skills you're looking for are either technical skills that they understand the bits of technology we work with, or generically the sort of things that we work with, and the softer skills, the management skills that go with it. We're a very heavily monitored, quality assessed, and contracted industry. So being able to writing things down is important, and so people who are good at writing stuff down and recording what they're doing, having a good approach to record keeping and time management, or all the other sort of typical portable skills you're looking for.
Okay, fabulous. I'm just scanning through the questions here, and I think actually your answer has probably answered a couple of them. I think we have one final quick question. The strangest thing you've ever tested, or most interesting test procedure?
It will go back to some of my older things, probably other bits. In my previous job of working with ARM, we did quite a lot of archaeological work. So I did some work on a thing called a Dacian battle scythe, which is basically a sort of a thing that the Dacians, who is sort of I think it's now Romania, used to repel the Roman invaders during the 1st century BC. So we actually made some instrumented Dacian battle scythes. In fact, a collaborator who was a blacksmith made us these things up, and we then used them to attack mock Roman helmets, which he also made up for us. And what we were trying to do at the time was to assess some archaeological finds which showed that the Romans had updated their helmet design in response to the threat, and we didn't quite understand what they'd done, because slightly strange way they'd attach things to the helmets, and they didn't seem to really make the helmets any stronger. And what we were able to show was that actually they'd attached some ribs on, and what they did is that when you tried to hit somebody over the head with this big battle size thing, it would deflect it out the side and tip it off the side of the helmet. And the other thing they'd gone is to wearing shoulder guards that the gladiators wore, and they'd started equipping the soldiers with these. And so what would happen is the blade would hit the top of the helmet, slide off the side, hit the shoulder, and come off. Whereas in the helmet before that, the blade would just dig into the helmet and cut their head in half. And so the eventual aim was to then go back for the archaeologists to go back to a battlefield and try and look for injuries in skulls and things recovered, to see whether they could see whether these were recreated. So we did quite a lot of that. And so there's certainly both the historical stuff and modern stuff. So particularly the human stuff. So I think that's probably the most things. The only other thing I would have mentioned is one of my colleagues did some work on shooting into fruit to see what happened. I can't remember exactly why. That was very messy. I seem to remember scraping melon off the roof of a ballistic test range.
Well, you're not doing that in my house. I'm going to stop you right here, and thank you very much for a very interesting talk. We are going to move swiftly on to John Chinner, who's the Principal Electrical Engineer and Facility Leader at Airbus Defence and Space Engineering Academy. I think John is ready to take control here. Hi, John, I can see you.
Hey, good morning.
Good morning.
Right, over to me, is it?
When you're ready.
Perfect. Good morning, everyone, and thanks for joining this webinar. My name's John Chinner, and I am an engineer with Airbus Defence and Space. Now, you might have heard of Airbus. If you've ever been on holiday anywhere and flown from the UK, there's a high chance you've flown on an Airbus aircraft. But I work for the part of Airbus called Defence and Space, where we build spacecraft and military aircraft and other things. So it's a fairly large company, Airbus Defence and Space. It's spread all around Europe and some people in North America and out in China and places like that. So it's a big global footprint. But I work in the UK. And in the UK, we've got in Airbus lots of sites around the UK, but in Defence and Space, our prime sites where we've got the most people are in Newport and in Stevenage and in Portsmouth. And Portsmouth is where I work. There's around about 1,000 people at each of those sites, so around 3,000 people in the UK. And we do lots of different things in Airbus Defence and Space, particularly in the UK. So a few years ago, if you remember seeing things about Mars rovers, there was a Mars rover called Rosalind Franklin that was built, assembled and tested here in the UK up in Stevenage. And we build satellites, so space probes, communication satellites, so solar orbiter up there orbiting the sun, monitoring the sun, getting in as close as they can to the sun to take some really great scientific observations of the sun. That was built in Stevenage. And where I work in Portsmouth, we're sort of a center of competence for telecommunication satellites. So not a satellite that will be sent off out into space to do some science, but actually a satellite in orbit around the Earth for telecommunications. Now, one of those ones that you probably have used or at least seen part of is the Sky TV satellites. They're called Astra. So if you look at houses around the UK that have got satellite dishes on them, or you've got Sky TV at home, you've got a satellite dish, those dishes are all pointing out into space in the same direction. So if you always look at those dishes, they're always pointing the same way. And they're pointing to a constellation of satellites called Astra out in geostationary orbit. And they are beaming down those TV signals to you. And those were assembled and tested in Portsmouth and then shipped on to our site in Toulouse for the solar array to be added and to be finally tested, and then shipped out to Kourou in French Guiana in South America to be launched into space, into that geostationary orbit. So there's lots of really exciting things we're doing in Airbus Defence and Space in the UK, but it's not all space, it's not all fired up into space. There's lots of work on the ground, anchor station networks, and our site in Newport is a big key hub for cybersecurity. So if you love cybersecurity and coding and things like that, then there's an opportunity for you to join Airbus Defence and Space. It's not all about spacecraft and rockets. So my job, I've had several different jobs in the company. I joined Airbus when it was called Astrium, And it was in 2010. I came from the Ministry of Defence. I was a technical officer there with the MOD, and I joined what was Astrium at the time, and now become Airbus Defence and Space, as a installation design engineer. And my first job was to go out to Abu Dhabi in the United Arab Emirates and design the ground station for 2 new satellites that were coming for the UAE. And I spent a lot of time in the desert building from a sandy pit to a proper ground station with antennas to control the satellites and take the data down and send the data up to the satellites. That was my first job. From there, I moved into satellite communications for ships. So I was designing terminals for ships, so satellite communications for ships. So for when ships are at sea, they can communicate via satellite back to wherever they want to communicate that. My prime part was military, and a lot of the Royal Navy, the British warships have got 2 radomes on the side of their masts, and under those are some dishes that point to a satellite out in space called Skynet. Now, Skynet was built in the UK primarily, and it's launched out into space, again in geostationary orbit, and its footprint, the part of the Earth it can see, is basically the Atlantic and Europe. So anywhere in that area where the UK ships are deployed, they can use that satellite up in space. Now, the satellite Skynet is pretty big. It's a big satellite. It's about the size of a minibus. But we don't just build big satellites. We also build things right down to CubeSats. So I've actually got a CubeSat here today. This is a little CubeSat. You can see this thing here, a little bit of electronics inside, some solar panels on the sides, and these here, antennas for the radio. So these things, CubeSats, stack the rockets full of these little CubeSats, deploy them into orbit, and they can do some science right there. That's the future of satellite, little CubeSats like this. So there's lots of different things happening. So I guess the question is, what do you do? What do we do? How do we do it? I guess I'm an electronics engineer, right? So I love all things electronics, and I can apply my electronics background to lots of different things. So I've been designing ground stations, been designing satellite communication terminals, and I even worked on the Zephyr high altitude solar powered uncrewed vehicle. Now, if you're really interested in nerdy stuff and seeing some really cool things happening that maybe aren't in space, go and Google Zephyr. Airbus Zephyr, you'll find this beautiful airplane, solar powered, flies up to 70,000 feet, twice as high as a jumbo jet, and entirely solar powered, charges its batteries during the day using the sun, and flies overnight using those batteries. Now, it's very, very difficult to do. The airplane's very light, and it's very tricky, but Zephyr is the only aircraft that has proven itself to fly continuously in the stratosphere, so 70,000 feet. Lots of other companies coming along doing a similar sort of thing, but it's very interesting to see what you have to do to build an airplane that can fly that high. Solar powered, it's collecting all the energy it can from the sun during the day to keep it flying that high overnight, and that kind of thing. We call it a sky hook. So if you think about it's called a high altitude pseudo satellite. So it can operate like a satellite, but with a bit more capability. So if you build a satellite and you want to send it up to space to take some images of the Earth, you send it up into orbit, and it's constantly orbiting the Earth. So maybe once every 90 minutes, it's going around the Earth. And if you have a camera on that satellite, it can only take images of the area that it's overflying on the Earth, and that changes because the satellite is orbiting and also the Earth is rotating. So a customer might say to us, we want to take a really high res image of the pyramids. And we would say, great, the satellite is going to be overflying the pyramids at this time on this day. Does that work for you? And they go, no, we want to capture something specifically at this time. So what you can do with an airplane like Zephyr is you can fly it with a very similar payload, a very similar camera over the pyramids. And essentially, because it's an airplane, it's flying at 70,000 feet, it's not required to go into orbit. It can just stay there, and it can take those images when you need them or wait for another one the next day. And the Skyhook thing is, it's not just a camera you can put on that thing. You can actually fly it up to 70,000 feet with a cellular base station for mobile phones. And suddenly, if there's a disaster and all the infrastructure gets wiped out, you can fly this Zephyr airplane from somewhere else in the world. It takes a few days, but it can go to basically anywhere in the world. And then it can enable mobile phones and radio systems to work in a disaster zone. So there's lots of areas for development for products like that. I'm going to give you a little bit about my career. It's not particularly interesting, but okay, I'm quite happy. I'm a space nerd. I'm working in a space company. I'm not talking to you today from an Airbus Defence and Space facility. This is my cabin in the garden where I work from home a lot of the time. So I keep saying I'm an ex-apprentice. I did an apprenticeship, and I'm a big advocate of apprenticeships. I started an apprenticeship in, and I hate saying this now, 1999, last century. It's so scary. I'm getting old. 1999 to 2002, I did a technician apprenticeship with the MOD, and I left home and I moved to Portsmouth, where the apprenticeship was, and at college. I studied at college telecommunications engineering, thoroughly loved it. And while I was doing that apprenticeship, I was also working. In the last 2 years, I had 4 week on, 4 week off blocks where I was in college studying, and then I was at work working with the MOD, learning how to behave as an engineer. And that gave me a great grounding to be a technical officer with the MOD, which I did from 2002 to 2010 when I joined Airbus. Now, that 8 years, I did lots and lots of different things, and I'm a big fan of saying yes to opportunities that come your way, trying new things, applying for new things to see what happens. And a lot of that happened for me. I ended up, when I left the MOD, I was living and working in Washington, DC. Fantastic place to live and work. And I was, of course, a space nerd. I'm in Washington, DC. I lived about 10 minutes from the Air and Space Museum, so I was there most Sundays. And I really started to absorb this feeling of space and the fact that I really loved space, and it really drove my passion. Now, I have a passion for engineering. When I was growing up, I was playing with Lego all the time and building things, and much to my parents' disgust, taking things apart, seeing how they work. But that was building my brain as an engineer. I didn't really know it at the time, but I really enjoyed doing it. So coupling that with being around the space environment in Washington, DC, I suddenly realized, look, I need to do something with this passion I've got for engineering and this passion I've got for space. So I went out and looked on the job market, and I saw a job, and I thought, well, they're asking for someone with a degree. They want someone to design infrastructure, which I know I can do. So I'll put my CV in anyway and see what happens. And you know what? The phone rang almost immediately. They said they want to get you in for an interview. And I said, it's a bit tricky because I'm in another country. But I came back, did an interview. And they, you know what? They gave me the job. And it wasn't based on me meeting all the criteria in the job advert. It was based on me thinking I could do the job. And I had to demonstrate to them I could do it in an interview, but that was fine. So I took a chance on a job and I got it. And I was able to move across to work in the space industry, which I was, at that point, I was like, this is fantastic. This is amazing. So really, really lucky to do that. And based on the fact that I applied for a job I didn't think I was going to get, but I gave it a go anyway. I gave it a try. And I think that's a good message, is don't write yourself off, give it a go. And if you're not going to achieve it, then it's not because you didn't try. And I think, you know, those things, if you try for a job or you apply for something and you don't get it, it's not a negative experience. You can take away positives from that and actually develop yourself. You maybe ask for some feedback. What can I do better next time? And you can grow and grow and grow yourself. So you're not aspiring for that job you've always wanted all your life and applying for it on the first try. You've done some other things along the way that will challenge you and question you and help you grow as a person. Now, I'm really lucky because I joined a space company working in an office in Portsmouth, and I can just leave my office. I can walk across to the building opposite, go up some stairs, and I can look through a window and I can see satellites being built. And you know what? Even after 10, 12 years of doing that, it still makes me buzz a little bit on the inside that I can just walk across the road and have a look through a window, and I can see the engineers building satellites. These things are going to be sent into space, and you can see they're complex machines, and there's lots of love and attention that goes into building them. But what I like the most is the fact that I see in that room building satellites, our apprentices, our current apprentices in Airbus Defence and Space building satellites. So that really gives me a great feeling of warmth and great. We're not just a company that's high tech, but we actually get our apprentices to actually hands-on build satellites, which is pretty cool. So we have an apprenticeship scheme in Airbus Defence and Space, several different flavors. So there's a technician apprenticeship, a bit like what I did, where we teach you to be a technician. And this is where you would perhaps be learning how to build a part of a spacecraft or part of an aircraft or part of an anchor station. All very, very entertaining jobs and great fun. And we train you how to be an engineer on the job, and you go to college and learn at the same time. But we also have now brand new, hot off the press, technician apprenticeships, in degree apprenticeships. So you're still doing some of the work like a technician, but you're actually doing a degree as well as you go. So we will train you to be an engineer while we send you to university to get a degree. It sounds like an absolute no-brainer to me. Now, we have about 15 technician apprenticeships a year in Airbus Defence and Space, so not very many. And we have about maybe 10 degree apprenticeships. We also have internships. So if you go and do a degree, you can come and join us while you're doing a degree, maybe for a gap year. And you can also join when you finished a degree to come and join our graduate program. So we take engineers, project managers, finance people to come and join us once they finish their degrees. And then we give them some training and development and start their career going within the company. Now, there's some great opportunities there. Now, it's not high numbers. Okay, so what I'm going to say to you, if you're desperate to come and work for Airbus Defence and Space and get one of those apprenticeship jobs, go right now and have a look on our Airbus Careers website, because the jobs that we have are all advertised through there. There's no secret, there's no surprises. They're all out there for anybody to see. So you might have aspirations in the future of something that you want to do, but you don't know quite what it is you need to do to get there. Go and have a look on the website. Go and have a look on the airbus.com/careers website. Click on maybe junior jobs, so the apprenticeships, or click on professional jobs to see the jobs that we want people who are already qualified. And you can see what we're asking for. You can see the kind of level of qualifications that we're asking for. You can see the kind of level of experiences we're asking for. And you've got an opportunity to go and maybe set some things in place to get those experiences, so you don't find out later in life that you want to apply and you go, oh, I wish I'd done something earlier. You can now do those things. So there's no STEM club near you. Go and have a look and see if you can set up your own STEM club. Lots of resources online about setting up a STEM club. That kind of STEM club experience will do you good, but also setting up a STEM club is a really good experience as well. Actually, if you come to an apprenticeship interview and say to perhaps me, who's sitting across the table, I set up a STEM club because there wasn't one, that's a really big positive thing. And to me, that's even more positive than the qualifications you've got, because that shows who you are as a person. We want people to come and join who've got passion, who are self-starting and can understand what it is that we need and have got those tickets. So it's not just that your academic side is perfect, it's that you're a creative person, you like building things, taking things apart, understanding how things work, perhaps critical thinking, questioning things, not taking details directly and saying that's true, questioning those things. These are all skills that we need in the industry, and those things you can do for yourself right now. So there you go, bang on time, hopefully.
Perfect. Yeah, you are indeed. Okay, great. Thank you very much. So I just want to reiterate what you said. Particularly in the early career side, we're looking for promise in people and the way that people think, what drives them. You can train people, but you can't instill that drive and passion into people. All right. So what we're going to do now is we're going to go to about a 10-minute break, during which point we will have a number of our quizzes that come up. The questions that you're putting into the chat for John, we will revisit after our panelists session. What we will do after 10 minutes and the quizzes will return, we'll introduce our TAME panel members and start that session. We'll then return where you'll have a chance to ask questions to John and indeed to the other speakers and to our panelists as well. Thank you very much. Great. So I think that we're about to start now our panel session. And I can, oh, great. We see everybody's lovely faces on screen here. So I'd like to welcome you all to the panel discussion, where we have our tame set of enthusiastic panel members ready to answer your questions. I would like to invite the panelists to briefly introduce yourselves, who you are, what your current role is, and then we'll open the floor to a general line of questions. We have Tia. You'd like to introduce? Yeah.
Is my audio working? Conscious that my mic can play up. Perfect. Hi everyone, I'm Taya. I'm a project manager and I work within the Imaging Systems Division of RAL Space. I joined as part of the 2020 graduate cohort, and I did that after my integrated Masters of Geological Sciences at the University of Leeds. So yeah, did not come from an engineering background or a technical background as such. So whilst I've been here, I've worked on EMS, which is set for launch on the Peregrine lander early next year. And we've actually just delivered Punch as well, which got delivered to the Southwest Research Institute and will be launching on the NASA Small Explorer mission in 2025. So that's a bit about me.
Great, thank you very much. Next, we have Alex.
Hi there, yeah, so I'm Alex. I'm the Product Assurance Group Leader for RAL. I studied ancient history at Birmingham University, and then I got a master's in Assyriology at Leiden University in the Netherlands. So again, not a technical background. I joined the space industry in 2018 at a different company, worked my way through their graduate program and started taking on projects after about 9 months or a year. And then from there, kept getting larger and larger projects. In 2020, I joined RAL Space as a senior product assurance manager. And then in 2021, I became the product assurance group leader here. I now work on and look after the aerial payload. So what Ian was talking about earlier, and Ian had a small picture of. So I look after the full science payload of that satellite.
Fabulous, thank you very much. Next, we have Oyuki.
Hello.
Hello.
Yeah, it's me. Well, thank you, everyone. My name is Oyuki Chang. I'm a physicist. I did my master's degree in geophysics and then my PhD in solar physics and space weather. Well, my background is also not engineering. So I started at RAL Space as an international postdoctoral fellow, working mainly with the solar team. Then I started a new position at RAL as instrument development and research scientist. And well, in this role, I do a few different things. This includes software development for quantum communication satellites, data analysis for atmospheric and solar activity studies, observations of interplanetary scintillation, and space weather monitoring. This includes also some modeling and observatories, scheduling for IPS, interplanetary scintillation observations. I do a little bit of science, a little bit of engineering in my role, which is very exciting because I'm learning a lot about both sides. And before getting my current role at RAL Space, I had mostly a strong background in mathematics, physics, and programming, which I think helped me to achieve and understand the required knowledge for my future skills that I need for the role I have now. This is me.
Oh, fabulous, thank you very much. Connor.
Hi, my name's Connor Sandyford and I'm a thermal vacuum engineer at RAL Space. I've now been in this role for 4 years. I previously did an apprenticeship at STFC in electrical engineering that led me to RAL Space, and that was also 4 years. So I joined site in 2014 and became a full member of the thermal vacuum team at RAL Space in September 2018. And in that role, I've currently been looking after 2 of our large 3x5 meter test chambers where we've been installing various satellites for different missions, and we've been overseeing the conditions of the chambers and the instruments themselves during testing.
Fabulous, thank you. Last but not least, Max.
Hi, I'm Max. My story is exactly the same as Connor. We both work with each other. We do, so our answer is going to be pretty much as one, really. So yeah, I left school at 16, did an apprenticeship here at STFC, and then yeah, like with Connor said the rest, really. So
Okay, great. So I would encourage our attendees to drop questions that you'd like our panelists to answer into the Q&A, and we'll try to pick them up. What I'd like to do today is, instead of pinning particular panelists to ask for questions, I'm just going to ask generally, and people who want to answer to jump in, or multiple people can answer the same question. I think it's important to highlight that people are different, routes are different, careers are different, and there's space for all in this industry. So on my list of questions was what intrigued you when you were either growing up or doing your training to join a role in the space industry? Everybody's too polite to jump in first.
I'll take it.
Go first.
So I think for me, because like I said, not coming from a technical background, I mean, I had that dream of becoming an astronaut. I think everyone did from a young age. But I've always been fascinated by space. And when I was little, I always used to watch the NASA launches and countless documentaries and many planetarium visits, much to my parents' dismay. And I never thought I'd be able to actually work at it here in the UK. So I didn't actually think about it until after uni, and I was a bit lost on what to do. And then during my year abroad in Canada, I got to do a lot of astronomy modules, just by luck, at the university that I was going to. So we got to design a mission that was going to Mars and to Enceladus, and it was just something that I'd never thought of before, really, seriously. And then I think after I finished uni, I just literally typed in space jobs into Google, and this was on the 3rd or 4th page. So really just applied on a whim and thought, wow, that actually looks pretty perfect for what I'd want to do. So luck, I think.
Great. Anybody else want to weigh in here?
yeah, we're jumping if you want.
Go.
So as part of the apprenticeship, we get to go around all the different departments around sites, abroad as well. Like I spent 6 weeks in CERN as part of the apprenticeship, and one of the placements we go to obviously is RAL Space. So what interested me really was all of the different bits of kit that are coming through the chambers every day, and getting to see them all, and bits that actually will get sent off up into space in the next couple of years. So actually, you always sort of like, when you're younger, sort of heard about satellites, and you've always, you learn about it in school and that, but to actually sort of see one in front of you and be working on it was something which I found really interesting. So yeah, sort of a bit of a passion really from a young age. But
Great. I noticed that there's... Sorry, go ahead.
Sorry, I was going to say, I think for myself as well, it's almost that part of when you see about a mission that's on the news or that everyone's aware of, just to have that kind of element of, I was a part of that in some very small way compared to others, but still the same. I've had some involvement in that, and yeah, that was a really cool thing for me.
Very cool. I noticed in the chat, or the question and answer, there's a question for you two about what your top tip would be for a young person who's weighing up the pros and cons of choosing between an apprenticeship versus a university course.
Yeah, so that was a decision. I think both of us were, obviously when you leave school, and that school is always trying to hammer you to send you to university, because that's obviously sort of the main route basically people at school, it's all about 16 do really. So apprenticeships weren't really sort of advertised to us in school. They weren't at our age, which I think was, yeah, a bit poor really. But so then we chose to come here, which was one of the best decisions I've made in my life, to be honest. The experience we got, all hands-on work. And then we've also just completed our degree last year, we did. So we've also done university route through RAL, which was paid for by RAL as well. So we have all the experience of our role we've done for the last few years, all the hands-on experience, as well as the degree as well. So for me, it's a no-brainer, to be honest with you, which wash option to go with.
I think as well, leaving school, I myself, I don't know about Max, but I was still unsure about what I wanted to do. So choosing an apprenticeship kind of gave me also more time to kind of think about kind of what I want to do, where I want my career to go. So I've kind of gone through that journey, as well as learning new skills, as well as making different friendships in and out of the business. And I think it was a nice way to kind of guide me in a direction that maybe if I'd come out straight from university and gone into a job, I may have then decided this isn't something I'm as interested in. So you're kind of learning about yourself as well as learning a new skill as well. So that was something that was quite key for me.
Yeah, try before you buy and all that.
That's it.
Question for Alex. Given struggles to recruit in engineering careers at the moment, what do you think we can do to tap into people like you who don't have a technical background and encourage them to come to the dark side?
Yeah, absolutely. So for me, it was an outreach thing. I became friends with somebody who worked in the space industry, and like me, he had actually studied history at university and had subsequently retrained and gone into software and things like that. But talking to him about the different jobs that were available in the space industry was really interesting. And I actually felt, this could be something I could pursue, and looked into it a bit more as well, and realized, yeah, this does suit my skill set quite well. And so I genuinely believe that there is a job role for everybody in the industry. Like Ian was talking about earlier, somebody who's really practical, get your hands in, actually build the items. Look at Connor and Max, working on the testing and things like that. It's a different skill set again compared to Oyuki or Taya or myself. So really, it's a really broad range, and I think that it's just a case of get stuck in, see what's out there, see what's available, and yeah, try and find the job for you there.
Okay, fabulous. A question for Taya and Oyuki. So I guess when you think of the space industry or a lot of STEM industry roles, it is very male dominated, although that is slowly changing. How do you think we encourage more women into careers like yours?
Go.
So I would say for me, yeah, like working as a woman in a male dominated field, I think I struggled a lot at first with, especially in project management, with kind of telling people what tasks need doing, especially when these people are, experts in their field and they've been at the job for 20 years. And at the end of the day, I'm there as a project manager. I'm not there as an electronics engineer. I'm not there as an optics engineer. So they need to trust in me, and I need to trust in myself that I know what I'm doing in my job and can help bring them along in order for the project to succeed. And I think joining from a young age, you may not know what opportunities are out there for you. And I think what can't hurt is just going out there and looking for it. At uni, there are a lot of careers fairs, and there are a lot of public outreach from other companies, and there were some space opportunities, but not that many to hand. So I think in order to find those, you will need to look online, and you'll need to scour the internet, and you will find them. I know that there is, Women in Aerospace, which we are joined as an organizational partner, and I think there are also mentor schemes and things like that. So just going out there and, not being afraid to be knocked down. I think, honestly, you need to put yourself out there, and, the worst they can say is no. And you just try again. You've tried your best, and at some point something will stick.
Great, thank you. Oyuki, anything to add?
Well, yeah, as you said, this is something that is changing actually in these fields, and I'm very glad for that. In my experience, it's been tough in that sense that you have to trust you have to keep on going, and you will make you have to know that you yourself are you're going to make mistakes, but at the same time you're going to learn about those. So I think just keep on going, approach women in the field, talk to them, learn from experiences. And I have to say that I'm very lucky to be in a team with the mostly women on it. And that never happened before in my experience. And I have to say that it's a very, very good experience. It's a very different way to work, and it's a very mixed group that we have already. So I will say also to men to encourage women as well to join your team, to learn from you, from themselves, from everyone around, how to work in companion of with difference that came with it. So,
great, thank you. Yeah, certainly myself, when I started, I hadn't really considered what my route would be. And when I was in university, I took part, this is in Canada, in a Women in Science and Engineering. During 3 summers that we got to go and work in different National Research Council of Canada sites. And it really was an opportunity where you just thought, oh, okay, there is space for me, and I can not have the skills in this particular area, but I can learn them. And it's a great way to get your feet in the door and get yourself kind of toughened up in a way to pitch yourself forward for these roles. And certainly within RAL Space, I used to run a group in the Space Engineering Technology Division of project managers. And I remember that we almost had to check for bias in the opposite direction. It was almost entirely women in the group, which is a very strange statement in this sort of industry. Okay, going back to our questions, we have a question about how much freedom is there in choosing what project areas you work in?
So this is quite job dependent. So for my team, people can ask to go on to different projects and things like that. And actually, if that works with the full group, then actually it's okay to do that, and it's relatively easy to do that. We want people to be working on things that they're really interested in and really passionate about. In some situations, though, it is a case of where people are available, when they're available, and so there is an element of these are the projects that you will be working on. So it's about trying to strike that right balance, but generally we try and make it so that people are working on what they want to be working on and interested in working in.
Okay, great, thank you. A question for Max and Connor. You mentioned work putting through a university degree. Which degrees did you go for, and how did it help you in your current role and what you see yourself doing in the future?
So we did electrical engineering design at Bucks New Uni. But through that, the route you do through the apprenticeship, you do your MVQs, H&Cs, H&Ds. So you sort of do small steps up to it, and then you work up to it, obviously up to the degree. Otherwise, like you would a normal degree, you just go straight there for 4 years. I personally preferred our way because we've got a lot more experience, a lot more hands-on experience. It does take a little bit longer, but the experience you got out of it is so much more valuable compared to just going to university, I'd say, because the hands-on experience has been, invaluable, really. What was the last part of the question, sorry?
How it helped you in your current role and what you achieved what you hope to achieve in the future.
So just sort of keep going on, really. There's options of masters to continue on to. Both of us have paused at the degree stage at the minute, just because we've been in education ever since we left school. This is the second year out of the education now, really. So it's sort of nice to take a bit of a break from it. But a lot of people have a bit of a break and then go on to the masters later on. So that's an option we would consider in a couple of years' time. It's helped us, every day, to be honest. The stuff we've learned at college, we sort of put into practice every single day, every day, sort of day-to-day role, really. So it's helped us a huge amount. We wouldn't be where we'd be now without it, basically.
Great, thank you very much. Imposter syndrome. Does anybody suffer from it, and how do you cope? I'll stick yes, 100% of the time.
Yeah, absolutely. I think everybody does it at some point, and And if they don't, I'd be quite interested to talk to that person, to be fair. For me, the average age of the person that does product assurance is about 50 years old. So I'm considerably younger than that, although I know I look about 50. But yeah, it's quite an interesting thing. A lot of them have been systems engineers or a different type of engineer and have come to product assurance later on in their career. So being able to go into those conversations is difficult, and you can feel like you're not generally the right person to do that. There's only 4 people that look after science payloads in all of Europe, of which I'm one of them. So yeah, I definitely get that imposter syndrome. The ways that I deal with it are making sure that I'm as prepared as I possibly can be going into any conversation, trying to get as much background information, trying to make sure that I know what the other person is trying to get out of the conversation as well. It's sometimes the case that you go into a meeting or a conversation and you think someone else is trying to get something else out of it, and it actually makes the situation worse just because of that bit of miscommunication. So by making sure that you're as prepared as you can be and knowing what you're trying to get out and what they're trying to get out, actually you can help curb that quite well, and you can make sure that you'll still feel like you've got imposter syndrome, but at least you feel like you're prepared going into that conversation.
And I think also remembering that you don't need to know all the answers, and that it's totally legitimate to say, I don't know.
Yeah.
And let me hand you over to my perfectly competent expert colleague who can answer this.
Or say, I'll give you the answer in a week's time or a month's time or whatever it is.
Anybody else want to weigh in here?
Yeah, I just wanted to say, like, I always used to think of imposter syndrome as being a bad thing, but it also, I think, gives an element to, you know, you really enjoy your job and you really want to be good at your job, and it pushes you to do that because you want to feel as if you fit in and you actually belong there and they chose the right person for the job. So as long as you're not letting it negatively affect you, and, you know, like Alex said, if there's something you don't know the answer to, it's okay to say that, and it's okay to do more research on that, and it's okay to maybe eventually get back with an answer on that if there is one. But it's a good thing to be able to push you to do better in yourself.
Thank you. Do you think it's better or easier to work in a bigger or smaller group, or I guess organization in the industry?
Projects tend to be made up of very large groups of people. So taking Ariel, for example, we had a meeting recently of most of the engineers that come from the various companies, and we had over 250 people at that meeting. So that works as a very large group, but that is dealing with everything, absolutely every element of a satellite. What you tend to find is actually most things boil down to quite a small area. So if we're thinking about cleanliness and contamination control, which is under my responsibility, that will be 1 or 2 people of those 200 that are really looking at that. And so it's quite, although it feels like a big thing, and in some elements it will be thinking about instrument interfaces or things like that, it is a big group, but usually you end up working as a small group. I think you need both of those. For the more traditional space side and not CubeSats, you need both of those elements to really pull it all together. When you start moving towards CubeSats and new space, it's a bit more agile and you can do it in different ways. And from my experience, smaller teams tend to get that across easier.
Okay, great. A question for Oyuki. As a physicist going into a job with a mixture of physics and engineering, what did you find difficult and what did you learn? And how did you decide to go to this sort of mixture instead of staying pure physicist?
Well, I'm going to start with the last one. I think it was the opportunity that I had when the position that I have now was open. So I was doing research on space weather, which is basically part of my job, and I really enjoyed that. So the position that was open the moment that I finished my postdoctoral project was a mix of those. And the only thing that I knew at that time is that I was willing to learn. And I always found putting in practice all the theory that I have in my head in a lab in hardware and programming. So for me, it was challenging. I have to say the first months I was learning something that I didn't know how to do, which is programming hardware and electronics. So that was completely new for me. But to be honest, even if it was hard, I knew that it was something that I was enjoying, the learning. So now I feel more confident of that knowledge that I got during my role, which is one of the things I will say that I thank to the company that gives you the opportunity that you have the skills and you have you're willing to learn, so you do it. Yeah, I think that's what happened actually.
Great, thank you. Another question here: biggest achievements or proudest moments of your career thus far?
This is a tough one.
Well, I have one that is maybe the highlight, and it was when I got my postdoctoral fellowship when I entered into the program. When you finish your PhD and you're asking for postdoctoral positions all around the world, you have to work hard on proposals, and you have to, have a very strong idea of what you want to do in the project. I didn't expect it. I took the interview. I passed to the interview here in the UK, and I got it. So I think that was one of the biggest achievements that I had.
Great. Others? Have you selected yet?
We just finished one of the test campaigns for Senator 4, which went on for nearly a year. It did in total, all the testing. So we just came out of a six-month singular test a couple of weeks ago in one of the vacuum chambers pictured behind Alex. So that was us working on it about 3 years ago now, when it was just the bare bones of it. It's come a long way since then. So we built the whole system from the ground up. So if actually start to finish, and then to see a satellite get put in, go through a full test, and then come out of it, I think was quite a proud achievement for our end, because we put the last 4 years work into it for literally this reason, to see the satellite go through and work. And as far as the test goes, it went very successfully our end. So it was great to see that with happy customers, really. So it was good to see it finally being used. All the efforts paid off. So
that's really satisfying, isn't it, when you get to the other end and
especially for us as well, because that's been our 4 years that we've been in the entire role. It has essentially been this one mission or this one stage. So to see that from literally the start through to the end is a really cool thing for us, and then exciting to get involved on the upcoming ones as well. So
great. Alex, here, do you want to weigh in here, or shall we move on to the next question?
Yeah, I was going to say that the first satellite that I looked after an instrument build, and seeing that get in space and watching that launch on YouTube. We watched it as a project, and quite humbling, quite emotional. Definitely big proud moment for me.
I think for me, ask me again in 2025 when hopefully Punch launches, and my answer might be different then.
Very good. It's funny how you look back on things, and how, when you get to the end of, building and testing an instrument, you're just so kind of emotionally strung out just by wanting to get it delivered, wanting to get it working and launched, that often when you get to the launch, it's, I don't know, like you almost can't believe it. And the moment is really exciting, but it passes you by, and then you look back on it and you just think, wow, that was actually really, really cool. I had a moment with my daughter, who's 4, a couple of weeks ago, and they're doing space rockets at school. And she had, as we were coming out of a pickup, she said to one of her friends, well, I've seen a space rocket take off. I was in mummy's tummy. I looked at her belly button. And you just think, yeah, actually, that is quite cool, isn't it? If not factually correct. Right, moving on. Computer science and programming, how does it tie into the space sector?
So we have a software team at RAL, and they literally sit above my head. And they obviously, software in space is really important. It's really key. And one of the key things for it is it has to be very, very accurate. if you're making a computer or a laptop, it's actually quite easy to change the software. Once it's in space, it's a lot harder. Getting people up there to physically change it, next to impossible. So yeah, it needs to be able to communicate back to Earth very clearly. But there have been times when satellites have been launched and there's one bit of code that's wrong, and it's meant that the satellite can't actually communicate back to Earth. The first launch of Ariane 5 failed because of one line of code. It was copy and pasted from Ariane 4, and it meant it didn't work. So computer science and programming is really, really important, and it's a really exciting area. It's developing quite quickly at the moment, being able to get satellites that can use AI and things like that when they're in space, make decisions, be able to know when and how to land on uneven surfaces like the moon and Mars and comets. Really, really important. And so yeah, there's absolutely loads of availability. We have a software specialist within my team as well who looks after the accuracy and quality of software being delivered. So yeah, really important.
I'd also highlight there as well that we have lots of people working in the science side as opposed to the engineering side, whose day job is effectively programming and writing the analysis software that takes the data that's coming down from these instruments in space and turns it into, you know, how much CO2 there is in the atmosphere, how much water vapor, what the wind speed is like. It's kind of the upstream and downstream side of things. Sorry, I'm just looking.
Yeah, just to add a little bit, because that's exactly what I do. I can mention several ways to use programming in this field, like different languages. At the moment, I'm programming software for satellite, which is embed software, and that is C. I'm also using tools from Python, Java, and other stuff. I mean, they're like different tools that we use to analyze data, to program, and to create everything that we need to do it. So programming is very, very used in this.
Okay, great. So a quick question about skills. What skills would you recommend learning as early as possible in order to give yourself a head start if you're considering a career in the space sector?
I will say physics, maths, and programming. But that's because I found quite useful for me to move from one discipline to the other, having this background and the basic concepts. So I will say that.
Okay, great. Anyone else?
Going down go Matt.
Sorry. I was just going to say, for myself, I think I had a very limited engineering background coming into the apprenticeship, and the majority of the skills that we have now we did pick up through that path. But before that, I'd probably say in my kind of like GCSEs and even like A-level options, I chose kind of design courses and kind of resistant material courses where you kind of get more of a hands-on role with kind of different kind of basic elements of engineering, but there are early skills that you even pick up at that sort of stage that I think are very useful, even kind of to this day, really.
Okay, great. Alex?
Yeah, I have quite a different route as well. So for me, inductive reasoning is a really important one. So being able to pick up patterns as they're emerging and know sort of how that's happening, why it's happening. Being able to read huge amounts, whether that be data or text. Do both of those every day. At one point in my degree, I was reading 6 books a week, so I got very good at going through a huge amount of information very quickly and being able to pull out the items that were incorrect or inconsistent. And the other one is root cause analysis, being able to find out exactly why something has gone wrong, where it's gone wrong, how it's gone wrong. And all those three can be sort of rolled out into almost any industry. So I think they're quite good skills to have.
All right, wonderful. I'm just reading questions here. How can a graduate looking to joining RAL Space in the future with a MEng qualification in mechanical aerospace engineering There are universities which offer specialized courses that you can merge two engineering themes in your degree.
So we have a graduate program that's usually open in September and October. And so it's closed for September's intake in 2023. But next year we'll open again. There will be jobs in quite a large range of areas. It's not in every area, but in a really quite a large range of areas. So that's one way. But there's also just the standard jobs. If you don't want to go through the graduate program, or you would like to try and apply soon, and that we frequently have jobs put on our internal website and external facing website that you can apply to. So if you just Google UKRI careers and then select STFC, that's where you'll find RAL Space.
Okay, great. We have a question, but I'm not sure whether or not this might be better answered by Ian. A generic aerospace engineering eng, what kind of learning it would take to work as an embedded control systems. Does anybody online know anything about embedded? Perhaps we take this question offline and we can answer it separately. If somebody,
yeah, I would say answer offline, but the one thing that I do know is our sister company, which is Daresbury Lab, based just outside Manchester, has an embedded control systems team there. So they specifically look at that. So that will be something to look into. So that's part of the STFC group as well.
Okay, very good. Thank you. Okay. What we've heard about the highlights of your careers. What's the biggest failure you've had, and how has it helped you overcome challenges in your day-to-day roles now?
So for me, this was probably about a year and a half into working in the space industry. I was running a fairly large but a very fast project, and we had a problem on it. It was a relatively minor problem, and that was sort of how I approached it. And when I spoke to the customer about this issue and explained it to them, the impression that I gave them incorrectly was that we weren't taking it very seriously. We would get it fixed, but it doesn't really matter. And that was the complete wrong impression I was trying to give them. I was trying to give them the impression that we were fully in control of the situation. We knew how to fix it and we'd make sure that it wouldn't happen again, but I just didn't communicate that properly and well enough. As a result, it meant that actually this quite a small issue became a very big issue. And I spent a lot of time trying to recover that good working relationship that we had with our customer. It'd taken us years to build up that relationship, and it didn't take me very long to do some damage to it, unfortunately. We did get back to a really good position, but it took a couple of months to get us back there, which was just because I didn't communicate well enough. So for me, one of the really key things was learning how to approach any issue, whether it be big or small. I now approach every issue like it's a huge major thing, and that I'm going to give it absolutely everything and make sure the customer knows that I'm going to give it everything to stop this happening again and put their hardware so that it is in perfect condition again.
Okay. Anybody else have something they'd like to share?
Yeah, I've got one example. So one of the projects that I was on, I won't name it for reasons, but the customer was coming to pick up the hardware. And so they came into the office around 8 o'clock in the morning. I think their flight was around 1 o'clock. And the paperwork to actually take the hardware over to the States was not ready. Yeah. So that was quite frustrating in the morning at 8 o'clock when absolutely no one but myself and the customers were actually in the office. So there was a lot of running around and editing PDFs and all sorts to actually get things to the point that they needed to be. It did help that, the customers were very, very chilled out. They were very understanding, very nice. Once I had them set up with a cup of tea and coffee, they were absolutely fine. And we did manage to get it sorted in the end. But I would say that was a period of high stress for a good hour. And I think that aged me about 5 years in just that space. So these things happen, and you've just got to you know, be a bit more prepared the next time it comes along. But sometimes things are just out of your hands and you've got to roll with the punches, I suppose.
Okay, great. Thank you. Anybody else want to feed in here?
I think we've had our fair share of problems, basically. They're more sort of mechanical, electrical problems, really. Stuff not quite being fitted correctly. Or one of the problems we had on one of the chambers a little while ago was it cools down using liquid nitrogen to get to around minus 195 degrees. But it has to be fully leak tested to make sure none of the nitrogen's leaking out, which means testing every single joint on the chamber, and there's hundreds of them. So we make our way through finding it until we had this one that was leaking quite badly, but in a chamber of obviously 5 meters wide, it's quite hard to find, and it took us weeks and weeks to find it. In the end, one of the pipes had an incredibly small, probably 2 millimeter crack that was thinner than a piece of hair. So finding that inside the chamber was a really big, like, needle in the haystack problem, basically. But we had to find it, so we persevered basically and just kept going and going and going, and eventually we did find it. But it was incredibly frustrating, a few weeks trying to find a problem which you can't even really see. So problems like that you just got to stick with, basically.
Yeah, absolutely. Right, another question through. What would I say my biggest success failure is? A lot to choose from, really. I think probably my biggest failure is more of a personal one than a professional one, that I tend to second guess myself an awful lot, or to overthink things. And it's one of the feedback that I always get when I interview is that I should be more confident and not undermine myself when I'm answering questions. And I think it links with what a lot of the panelists have touched on here, that when you're, and indeed the speakers have touched on, when you're putting yourself out there, you're applying for roles, you're looking at interesting things to take on, to view it as everything has an element of success behind it. You might not get the role that you're applying for, but you're learning what you need to do in order to get that role. Or you might not handle this particular situation when you're mulling over it at 2 o'clock in the morning exactly the way you should have done, but you've had that experience point that next time you will do it better, or you'll be prepared better. And so for me, it's learning as my career goes on, what I'm comfortable with, where my shortcomings are, how I cope with those, and how I forgive myself when I mess up, which I do every single day, as I suspect we all do. We have one final question before we close our panelist section. Tips, general and technical, you would give a university student interested in joining the space industry, considering the joys of recession and impacts on the sector, and can it also impact on the recruitment process?
So one of the benefits of the space industry, which usually is considered negative, but actually in this situation it's a benefit, is a lot of our projects run for years. Again, taking Ariel, for example, that was started around 10 years ago and it will launch in 2029. And so you can see sort of the length of some of these projects. So that financial backing was allocated a long time ago and it's set. And so in a way, the space industry is actually slightly more protected than slightly faster pace moving industries are. So yeah, it's slightly better. There is obviously an impact of the recession, and you will see that some companies and organizations are reducing the amount of people they take on, but definitely don't let it deter you from applying. I think compared to most industries, it will fare much better in terms of consistency.
Okay, great. I'm just aware that we have gone a bit over time here. So I would just like to close the session here and say a very quick but heartfelt thank you to our panelist members, and in fact to everybody today, in terms of the speakers, our lovely audience and attendees, to our organizing committee who've made a massive undertaking here, as well as their day jobs to make this the success that it has been today. And I think that we've had a really great informative session. I hope you got as much out of it as I certainly did. We'd really love to hear your feedback of today, and we want this to be an annual event, and to make it as useful as possible to you. So do please feedback to us via the events email, so that we can either follow up on things that you didn't get the opportunity to ask today, or to also feedback things that would have made it more useful. We do have a bit of extra time here. So if you are interested in staying on the line to ask any space industry related questions, and I'm aware that we didn't actually get to have a question and answer session for John, who's still on the line, this is our opportunity to do it. We're able to stay on the line for another half hour. So I guess first question is, are there any questions for John? I'll try to find the Q&A to see if there are any ones that are popping up. This is when I need a bigger computer screen that I can get everything tiled and I can actually see what's going on and all the various. There is a question, inevitable to work on defense projects while pursuing a career in the space industry. Does anybody have a?
Well, I can jump in there. That's a really good question. And I get that quite a lot, actually, by the nature of the business I work in, called Airbus Defence and Space. So yes, a lot of our contracts are defence related, but not everything. And I think if you're passionate about space, but you wanted to avoid working in defence, it's definitely possible. And I think it's probably more likely in a company as large as Airbus Defence and Space that you can move around all the different areas and perhaps avoid the things you don't want to work in. But I guess there is a defence oversight to a lot of the things that we do. And again, like I said in my little talk, you can go and find a lot of information on the website about the products and things that we're doing. But generally, we don't recruit people for a particular program. It'll be a particular like skills need, and generally it doesn't show on the advert what the program you'd be working in would be. So it can be tricky to join, but certainly there's enough jobs within the organisation you could probably avoid it if you wanted to.
Yeah, I've worked on very, very few defence missions, even though I've been in the industry for quite a few years and worked on probably about 20 satellites now. So yeah, it's definitely not a must or an absolute.
And I think that people are aware, as an employer, people are aware that not everybody wants to work on defence and that there are other people that are quite happy working on it. So it's something that we are very used to, accommodating everybody's particular moral compasses and no-go zones. Any other questions? We have both Ian and John from our speakers.
I can't answer that question about the embedded control systems. I think Alex did the right answer. So it's not an area. I think that RAL Space at Harwell has any significant interest in, but it does be maybe a place to go. Wasn't even more linked. Yes, I don't understand this answer. I just see it come up a more detailed one saying, well, I don't know is the answer.
I mean, embedded control systems. I mean, I'd like to find out a bit more of detail about what the specific example was from the person, but embedded systems is something that we're growing definitely in our business, and in terms of like FPGA embedded into satellites, reconfigurable satellites that you literally change the frequencies, change the way they work while they're in space. So embedded systems is actually, it's quite a broad topic, but certainly embedded systems definitely occur within the industry I work in for sure. And I know people, it's actually a growth area, particularly if you're talking about embedding an FPGA processor into your product, then the people writing the code, the VHDL for that, are quite a scarce resource right now. And globally, FPGA embedded processors like essentially hardware, but with running some software, it's a growth globally. So there's a real pull on engineers with that need and that skill. And we're always recruiting for FPGA engineers, and it's got to the point now where we'll take people that have very limited experience and train them internally, because we just can't find candidates in the marketplace out there.
We have a question specifically towards prepping for an interview with RAL Space, but I'd like to widen it out to prepping for an interview in any space industry. How would you guys prep yourself for an interview, and what are you really hoping that the candidates that you see as a recruitment team, what do you think they should have done their homework on?
I can answer this one. I think for an interview, it sounds hopefully simple, but know what you're applying for and know what they're asking for, and making sure that you're actually hitting all those points. I think a lot of the time, a job can give you the template for exactly what they want, and people will totally miss that when they're sending in CVs, cover letters. So I think just make sure you're actually reading the question essentially and making sure that you're answering it. And when you go to an interview, it sounds so cliche, but just be yourself. The person that is recruiting will know if you're right for the position and right for the role and what they're looking for. And what you don't want is to be putting on a show and then you get the job and you get there and actually it's not the right fit for you, and you may not be the right fit for the place either. So I think you need to trust that the recruiter knows what they're doing, and you're stepping into roles that you actually really want to do and that you're actually really passionate about, and you have the skills to actually cover it, or you're more than willing to learn those skills. So yeah, I think that's what I'd have to say on that, to be honest.
What I always do before an interview as well, as Taya said, you have list of criteria that people are looking for, and it's really easy to say, oh yeah, no, I've got experience in doing X, but what a recruiter actually wants you to say is, this is when I did X. So have an example, have 5 examples in your head that you can shift and you can use to talk through example of when you did this. And it doesn't have to be in a work situation. It could be in your personal life or in one of your extracurriculars, but have these demonstrated examples that you can say, here is me doing what I said I could do on paper, but in the real world.
Yeah, and just to complement that a little bit from I remember when I applied for my apprenticeship scheme, I actually took a robot I'd built along to the interview with me and put it on the table and switched it on, and it walked backwards off the table. Now, one thing that did was demonstrate I could build stuff, which was what they were essentially recruiting you for, but actually it made you a memorable candidate as well in front of the interviewers. If there's a large selection of people going through, you make yourself stand out. Take something you've done. If you're applying to be a mechanical engineer, perhaps if you've designed 3D models, printed them on 3D printer, just bring something along in your pocket and say, look, I've done this, and this is a physical manifestation of something I have done. And I tell you, those kind of things really help out the people on the other side of the table to understand who you are and really build a case for you.
It's also worth saying that when you go to a job interview, they're also interviewing themselves, essentially. You need to know that where you're going to work is going to fit for you. So you might fit for them and they might offer you the job. But if you think, no, this isn't quite right for me, I don't quite get the right impression or the right vibe or whatever it might be, then that's not right. Don't go and work there, because if you're getting that impression just from a 30-minute, hour, 2-hour conversation, that probably means that place isn't the right place for you to go and work.
Absolutely. Question, what do you wish you'd done more of throughout your career?
Gosh, that's a tough question, isn't it? No, I guess I'm fairly satisfied about the direction I've taken, and perhaps I was a little bit. I didn't have a master plan. I didn't have a 10-year plan, and I think that probably happened organically. Now I think that I've realised that worked well for me, and that my 10-year plan was to not have a 10-year plan. and to say yes to opportunities and say yes to things that come your way, even if they're a bit tricky or they're a bit abstract or a bit sideways. Say yes to it, because even if it doesn't work out, you've had a good opportunity. And I have done most of the amazing things I've done in my job have been because someone said to me, oh, this is a really tricky thing, I don't know how to do it, and can you help me? And I've gone and helped, and it's evolved into something else. So saying yes to those opportunities, and thinking back, there were lots of opportunities I didn't say yes to that I don't know where they would have led.
Absolutely. And I think that's one of the things about this industry. There are so many opportunities and opportunities to learn as well as do. My husband always does courses out of hours, and is always really frustrated with me that I don't want to do them. And I say to him, look, all day, every day, I have no idea what I'm doing. I am learning every single day during my day job. I don't need to have anything else other than what the opportunities that are coming towards me are already. And I think that's a really positive thing. Certainly.
Yeah, I think I can't think of anything. I think I'd agree with John and say largely I think I've done about the right things. There's bits where you think, I think in general it's difficult to generalize on things. I'd find it very difficult to say, oh, I should have done more of this or more of that, because in the end it's a sort of whole wrapped up of all the different things you did, and if you knew in advance what stuff was going to work, then yeah, I'd volunteer for more than that. But I think you just got to take what comes and take the opportunities as they arise. If somebody says, can you do that, and it looks interesting, so it comes back to the imposter syndrome thing. If you don't volunteer to do it, somebody else who's rubbish at it will volunteer. So you might as well do it and have a go at it rather than relying on somebody else who may be a lot worse than you. So if you get an opportunity, take it.
A couple of questions coming through. Which coding languages and skills would be the most important to learn for the sector?
It's quite difficult to say a specific coding language, but I mean, I'm going to highlight something I've worked on in the past, which is AstroPi, where we've sent Raspberry Pis to the space station, so you can write code, send your code to space. That's Python, and I guess for me, the experience of doing that code, writing Python code, gives you an opportunity to see if you enjoy the experience of writing code, because it's not for everybody. But if you can grab some Python, start writing some Python and really enjoy it, then perhaps that's where you can think about perhaps coding and programming is a job for you. If you hate it, then maybe not.
In the more the soft side we work in, things tend to be quite conservative. So the answer is we wouldn't let anyone near anything doing coding, because you pretty much have to use software that's fully validated and verified. But I'd have gone for Python as well. I mean, that's probably currently the most useful thing. Although in my end of the business, we don't do that very much, because we are, shall we say, we need to be conservative on what we do.
Yeah, I can mention like a few languages that engineers and astronomers are using still, like IDL or MATLAB, and this is moving all the time. So it's not like one language that is essential for you to learn. It's more like learning algorithms and how computers think, so you can move from one language to the other with no more complication, because you then only have to learn the syntaxes and how that works, that the specific language works, but you will have in your head the algorithm that needs to be followed. So I will say it's just a general language. There is no one programming language that you can just follow. It's a little bit more. And yes, Python now, it's kind of the universal language for it has many libraries in astronomy and many libraries in different areas. So I would say that at the moment, that's the language that everyone is kind of using.
I would also say maybe Connor and Max might go, do you do PLCs and things like that?
So we use PLCs and we mainly wire to them, but we do minimal coding. The coding is coming into it now. We are starting to do courses, but it's all sort of basic ladder logic. We don't really use them too much, to be honest. But
there could potentially be a time where we're more involved in that side of things, but at the moment, because we're kind of still in our just coming out of our commissioning stage as well, it's kind of more beneficial for us to pull in other guys that are very much experienced in that area. But it's something that hopefully we'll be able to look at doing ourselves and kind of, yeah, get involved in the future, I think.
Okay. We have a question here about apprenticeship for young photographers who are passionate about photographing even space. Is there a career path for this? I don't know whether or not, Vicky, if this is something that you might be able to join on from our comms team. Is Vicky still online? Ah, there you are.
Hello everyone. So yes, I'm Vicky. I've been in the background here supporting our communication. So I work in the science communication team. So I did study astrophysics, but then I did some teaching and I also know some languages. I speak some German and French and Spanish. So I could combine those skills in science and communication to work in science communication. And we definitely do work with photographers a lot. And we also, and that's for a variety of different reasons. So it could be for photographing space. I'm assuming that's probably more the astronomy photography side of things. There are resources such as the National Schools Observatory, mostly for schools, but there are other robotic telescopes abroad that people can sign up to take their own images with robotic telescopes abroad. So that is an option that anyone can do. I know there's a couple of commercial ones as well for members of the public to sign up to. But other photography is actually really important as well, especially in getting across what our messages are. So for RAL Space, we have a lot of the engineering side of it. And throughout the process, it's really useful to record the journey that a satellite goes through, for example, especially to explain a lot of the technical language to a whole variety of people who don't necessarily have that technical background. So we work with photographers to get images of our equipment at different stages, of our facilities when we're building them, and also working with Alex, especially when we inspect spacecraft. That's also very important for the photography, so you could probably mention a little bit more on that, Alex. As for specific apprenticeships in that area, I don't know of any ones that we offer specifically, but I'm sure it's out there somewhere. I would definitely say, reiterating the messages that have already come across through the talks this morning, there will be something out there. And if not, I think the expertise is probably in the photography side of it, and then being able to apply those skills in the space industry and move into the space industry that way. That would be my recommendation.
Yeah, so within my group, we have quality inspectors and hardware inspectors to make sure that the satellite or satellite components are going to look exactly how we think they're going to look, and if there's any damage, we can capture it as early as possible. So yeah, there's a huge amount of photography that goes into that. To give you an example, there was one day in 2020 where I took about 2,500 photos in one day. So yes, there's a fair amount of photography and actual hands-on hardware. So if it's the photography side you like, then there is definitely a job. If it's more photographing stars and space and things like that, then it's a slightly more obscure field to get into.
But actually, I'd recommend joining a local astronomy group. There are local observatories that have local astronomy groups, and they have people who've been doing it for years, and they can recommend how to get into that, even if buying your own telescope or how to access some of the other resources online.
And I guess, in fact, what a lot of our instruments actually do is take pictures of space. So it's not necessarily you behind a camera doing it, but an instrument flying who's doing that. But yeah, different routes.
Yeah, building space cameras, we do a lot of that.
We do a lot of that. Are there any other questions coming through? I think we've started to slow down. In which case, and I don't know whether or not if our organizers can see anything that I'm not able to see. I've got our chat and the Q&A open. I would suggest probably that we close then for today. And just really a big thanks to everybody who's been involved, speakers, panelists, our great organizing team who've made this such a success today. And I certainly got an awful lot out of it, and I hope that you guys did as well. Emily, Hannah, Vicky, are we? Do all attendees have all of the information in terms of how they can feed back to us, how they can get in touch with us? to ask further questions, or so that we can direct them in the people who can answer their questions?
Yep, we've shared the links in the chat and it'll also be emailed out to everyone.
Great. Okay, thank you very much. Well, with this, I'd like to close today, and thank you to everybody for joining. Do please get in touch with us. Do please feedback. We want to make this a yearly event, and we want to give you what you want this event to be. But thank you very much.